Okay, so we're going to jump in and start thinking about what it takes to make a model. And anytime we're talking about making a predictive model, we're talking about predicting the future in some ways. And so I guess the first question to start with is just what does it take to do that? And in a really general sense, here's the idea. If you have a system and you know what it's like now, and you want to know what it's like later, the only thing you really need is how it's going to change. And so if you can understand and quantify these, then this is something you can determine later. And so having a way to describe a current set of conditions, like how do you describe what is existing right now? Is it a height? Is it a mass? Is it a velocity? Is it a number of people? Is it a population? Is it a plant height? Anything like that. Something that allows you to quantify the current state. And if you have some mechanism that causes that state to change, and you can also quantify the change over a certain time period, then you can know what it's going to look like later. And so the simplest example I could think of to get across this idea is if you started with like a brick and it's falling. And this is something that pretty much anybody who's taken high school science should understand, that this has a height, and at time 0, let's just say that that's 600 meters in the air, and we want to know where it's going to be like later. And in order to do that, then we need to know how it's going to change as the time increases from 0 to whatever we want to do. So this idea that it has a height, that's actually the primary variable that we're going to keep track of in this. And I'll draw this out like a table so that we can see how each of these variables and other parameters change as time goes on. So that introduces time actually as another variable. So if we're going to do this, let's just do it in 1 second increments. We probably won't get that far. Let's be realistic. So we're going to look 3 seconds into the future in this. I need to know how the height's going to change in that first second. And things moving, things that have a velocity, move because they have a position that changes because they have a velocity. And so the fundamental equation that explains how the height is going to be different 1 second later is that the height at time t is going to be equal to the height at time t minus 1 plus however much that's going to change, which is actually just the velocity. So if it's moving downward, it'll have a velocity that's negative. But this velocity here is the change in the height divided by the change in the time. And so that's actually the definition of a velocity, change in position over change in time. And so we'll also need to know the velocity. And at time 0, if we just have the brick at 600 meters and we let go of it, that velocity is 0. If that's the only thing we consider, then 600 meters plus 0, when at 1 second later, its position is still 600 meters. And actually that doesn't kind of make any sense because it's got to fall. And so the other thing that happens, things fall because gravity pushes on them, is that velocities also depend on time. So this is height as a function of time. This is velocity as a function of time. And there's also an acceleration. I'll put that way over here because it's going to be a different kind of beast. So the velocity at time t is equal to the velocity at time t minus 1 plus the acceleration. And the acceleration doesn't change, at least when you're near the surface of the Earth. So this acceleration here is the change in the velocity over the change in time. And so let's just call this minus 10. Everybody knows it should be 9.8 meters per second squared, but we'll keep the math simple and call it minus 10 just for now. So the acceleration is minus 10. So these are the variables. These are the things that we can keep track of, the things that we can observe. Then there are things that are changes, like what's the change in the height and what's the change in the velocity in any moment. So the change in the height is actually just equal to the velocity. So at time 0, the change in height, because it's not moving, is actually 0. The change in velocity is actually just the acceleration. And if I know how each of these is going to change, then I simply can add those to the current values. So the new height is going to be the old height plus the change in height. So these two values here added together is actually still 600 meters. Again, a little counterintuitive and in fact physically wrong. And the physical wrongness we'll get to later. The velocity is going to change by a certain amount. And so the velocity after a second has gone by in this discrete time step model is minus 10. And this is going to be in meters per second. At time 1, the new change in height is going to be equal to minus 10 because now it's moving. The change in velocity is still minus 10 because at least in this model, the acceleration doesn't change over the course of this thing falling through 600 meters. So now at time 1, I have a new set of values and I have a new set of changes that allow me to look forward one more time step. So if we go for the next time step in the height, this is going to decrease by 10 because the velocity at time 1 is minus 10. So this goes to 590. The velocity itself becomes minus 20 because the old velocity was minus 10 and it changes by another minus 10. So the change in height then at time equals 2 is minus 20. The acceleration is still constant, so that's minus 10, and we can go down to time step 3. So now at time 3, it starts at 590. It drops by 20 meters. So this becomes 570. The new velocity becomes minus 30. And you can see the effect of accelerating toward the ground, making an increased velocity, so the amount by which it drops every single time increases by a little bit as it accelerates and eventually will hit the ground. So it's a trivial simulation. If you wanted to ask questions about it, like how would you use this kind of simulation to answer any reasonable question, one question you might have is when will it hit? And if you wanted to use this predictive model to answer that question, what you would do is you would run it out, find h at t for all t until h is equal to 0 or less than or equal to 0. I don't know if it's ever going to be exactly equal to 0 at a discrete time interval, but when you find the one where it is negative, then it's hit the ground within the last second before that. And so this would be a way to answer a deterministic, this is a physics question, but it's a deterministic question based around the idea that we know an initial state, we know changes, and because we know changes, we can predict the state, both the height and the velocity at a later time. Now, I think I can add a new page.